Let's see. It looks like I got Kevin and Daniel here. Can y'all speak up?
Yes, sir. Hello.
And good to see y'all. I need a couple of you guinea pigs so I can teach to something.
This is Kevin.
Good to see you, Kevin. Yvette, are you there?
I'm here.
All right. I'm glad to see y'all all survived the storm, and obviously you got internet with your Wi-Fi and everything going. I need to remind you, Daniel, you might want to turn off all your other Wi-Fis except what you're using with this Zoom meeting. It does interfere with you sometimes. I know it does with me.
Okay.
I have to turn off my phone Wi-Fi. Okay, let me see what we can do with this. Okay, it's showing my screen. Mine is a smaller version. Anybody want to tell me how I can make that a larger?
I'm not sure.
I'm not sure either. I'll live with what we've got here. Okay, today we're going to cover section 1.2 and 1.3. And let's make a real quick review of what we did in that section 1.1. We had linear equations. There are 4 things you can do to solve a linear equation. You can add, subtract, multiply, and divide. So if we got x plus 6 is equal to 10, it is linear because what is its power? What's the power of x?
1.
1. Just speak up anytime. I need as much interaction with y'all as I can. So in this particular case, I subtracted 6 from both sides, and I got an answer of x is equal to 4. In the second one, I had x minus 6 is 10, so I had 6 to both sides, and I got an answer of x is 16. In the third one, I had x divided by 4. So I multiplied by 4 because that gives me 1 times x. How much is 1 times any number?
That number.
That same number. And then in the last one over here, I divided both sides by 3, and I got my answers 4. So that was section 1.1 in a nutshell. To solve a linear equation, all you can do is add, subtract, multiply, divide. So Daniel, you're going to find out one big step in our solving quadratics these days is that we get it down to a linear, then we have to drop back to that add, subtract, multiply, divide mess. Okay, but today we're going to look at quadratics. ax squared plus bx plus c. Write that down. That's a biggie. That is a quadratic equation. It is quadratic because it is second degree. Daniel, how many answers am I supposed to get when I have a second degree equation? 2. How many answers am I going to get when I have a third degree equation? We don't solve many third degrees, but Daniel, is going to be 3. In fact, that's the fundamental theorem of algebra. The degree of the equation determines how many solutions you're going to get. And we're going to work one today that's going to have 4 solutions. Okay, this is a biggie now. To solve a quadratic equation, I got 4 methods. I can solve them by factoring. I can solve them by the square root method. I can solve them by completing the square, or I can solve them by the quadratic formula. Now, in all of this glory, Kevin, the quadratic formula, it should be your last resort. And that because you're going to see how much more time it takes to use the quadratic than it does to use the other methods, okay? So Daniel, I'm going to try to make believers out of y'all in the other methods before we do the quadratic. Fair enough? Okay, but before we do that, we got to back up and punt. We got to go to something else. Who remembers what FOIL stands for? FOIL.
First, outer, inner, last.
First, outer, inner, last. And I want y'all to have it in y'all's brains, Yvette, in that order, okay? Because I'm telling you, if you'll FOIL in the correct order, you're going to be able to factor in the correct order. Because factoring is just a reverse of FOIL. Listen to what I just said. Factoring is going to be the reverse of FOIL. Okay, so I took an example here. I got x plus 3 times x plus 4. First term, x times x is gonna give me x squared. Outer is gonna be 4 times x. Inner is gonna be 3 times x. Last is 4 times 3, which is 12. So I have two like terms here. 4x plus 3x is 7x. And then I have my 12. Now I want you to look at this mess, and I want you to listen to when I keep hollering that we're going to factor. Well, if this is my problem right here, the only thing you look at first is this 12. So it has three factors, 12 times 1, 4 times 3, or 6 times 2, correct? Now, how do I know that I'm going to use the 4 and 3 on this problem?
It adds to 7.
Amen. And if y'all will keep that in mind and see that as quick as you can, you're off and running. Listen to what he just said, Yvette. 12 and 1 don't get 7. 6 and 2 don't get 7. 4 and 3, I can get my what? 7. Makes big sense, doesn't it? Okay.
Yeah.
Yeah. I got x plus 3 times x minus 5. So outside, first term is x squared. Outside is going to be minus 5x. Inside plus 3x. Last is minus 15. Now, this is a biggie, and it is a biggie. How much is minus 3, and minus 5 and plus 3? Minus 5 and plus 3.
-2.
Good luck, Yvette. You can review it later. I'll have it posted for you.
Okay,
It's
thank
gonna-
you.
It's going to be -2, right? Now, so it's x squared minus 2x minus 15. Be careful with the sign. Make sure that we get those right. Agree? Now, let's soup it up just a little bit. Let's fall 2x plus 5 times 3x plus 4. Well, this time 2x times 3x is 6x squared, right? Now, my outside is going to give me an 8x. My inside is going to give me a 15x. And my last is going to give me 20. So I'm going to have 6x squared plus 23x plus 20. Fair enough? Okay, so that's 4. And if I promise you, if you'll do fall in the right order, Daniel, then you're going to be able to factor a whole lot more comfortable, right? And this next problem is going to give you, I hope, a good example of that. In fact, this is one of your homework problems. I got x squared minus 3x minus 40. Well, over here to the side, I would make that mental note. 40 is 20 times 2, 40 is 10 times 4, and 40 is 8 times 5. So why are we going to use the 8 and 5?
To make the -3.
Yeah, I can get a 3 out of 8 and 5, some way, somehow. Is that right? Now, I want you to listen to this next statement, and this next statement is crucial. And you're factoring this mess right here. You've got two products. The outside product is 5x, the inside product is 8x. You see this middle sign right here, that -3? The minus always goes with the biggest product. Welcome, Trinity. Good to see you. The minus always goes with the biggest product. Yeah, make yourself a note of that, Daniel. That's very, very important. Now, so the minus has to go with the 8. Somebody tell me why I would have to use a plus with the 5. That's just as important, Kevin. Why would that plus, that 5 have to be positive in this number? There are two reasons, and I want y'all to look at both reasons and understand them. You see this back end number is negative?
Yes,
Every time the back end number is negative, Kevin, these signs have got to be opposite, right?
correct.
One has to be plus, one has to be minus. Daniel, does that make sense?
Sir? Yep.
All right. Now, so once we get this first sign right, then we're off and running because the rest of it's going to have to fall into place for me. Let me see what I did on the next one. Okay, the next one I dropped back to something that way too often we lose sight of. Put that in your memoirs. Look for a common factor first. The problem is 3x plus 6. What can I factor out of 3x plus 6? I can take the 2 out, the 3 out, right? And it gives me an x plus 2. Now, this is important because this is one on the test and people miss this. The x squared plus 5x. Do you see that I can take out an x? And when I take out an x, I have an x times an x plus 5. Does that make sense?
So the x comes out of the parentheses.
That's right. And seeing it's the distributive property. So if I put my parentheses there, if I distribute it, I get my x squared plus 5x. Make a little sense? Okay. Now, so look at the problem. Here's the problem. And this is a really often missed problem on the first test, believe it or not. It's x squared minus 5x is equal to 0. Well, before we can work this problem, we need to talk about something else, but let's go what we know first of all. Can I take an x out of x squared minus 5x? That's what we just did up here. And it's going to give me an x times an x minus 5, right? Okay, now I want you to put this in your notes, folks. There's a little law. If a times b is equal to 0, then a is equal to 0 or b is equal to 0. Does that make sense? How much is 0 times anything? 0. So Kevin, that makes sense, doesn't it? If I multiply two things together and get 0, one of them has to be 0. In fact, both of them
Always.
can. Yeah, both of them can be 0, right? Now, look at our problem now. Our problem says that x times parentheses x minus 5 is 0. So that says x is 0. That's one of my answers. The other one says that x minus 5 is 0. I add 5 to both sides and I get x is 5. But the big deal is this. We got two answers. We got x is 0 and we got x is 5. Now, one more time. Daniel, why did I get two answers?
Is it because there's a binomial?
Well, okay, that's a good way of answering my question. The real answer is I wanted right here is second degree. Yeah, got that? And I'll agree. It was a binomial, it had to have two answers there. But it's second degree, it had two factors, and that's the reason that I have two answers. Now, watch this next problem now, because this is the kind that I'm preaching. I got x squared minus 5x minus 6. Well, I'm going to be kind to y'all, and I'm going to cut through some of the time. So I factor this mess into x and x, and for 6, I got 6 and 1, or I got 3 and 2. Well, I'm going to do it right to start with. I'm going to use the 6 and 1 because I looked far enough ahead to see that I had to do that. Because if I use 6 and 1, I get minus 6 and a plus 1. That would give me my minus 5. Now, minus 6 times plus 1 gives me my minus 6. Is that right? Okay, so what that says then is that I got x minus 6 is equal to 0. So that says that x is 6. And then the other one says that x is minus 1. Now, so I got two answers. I got positive 6 and I got minus 1. Kevin, how do you check a problem? Any problem, how do you check?
You plug the numbers back in.
Please, and y'all get that in your brain and do it when you need to. So Trinity, we're going to plug into 6. 6 squared is 36. 6 times 5 is minus 30. Minus 30 minus 6 is minus 36. How much is 36 minus 36?
0.
It's 0. So the thing checks, and I promise you, if you plug in that minus 1, it's also going to give you 0. Fair enough?
Yes.
Okay. Now watch this next problem. It's going to look like the same thing, but it's not the same thing. I got x squared minus 5x, and I got a plus 6 on the end. So this time, the factors of this mess are going to be x minus 3 and x minus 2. Now, why do they have to both be the same sign? That's important. Why do they have to both be the same sign?
Create the positive 6.
To make the positive on the tail end. So they either had to be both negative or both positive. Does that make sense?
Yes.
So this time right here, so you're going to get two answers. You're going to get x is 3, and you're going to get x is equal to 2. And both of those answers are positive. Well, let's try it. Let's check the 3. 3 squared is 9. 9 plus 6 is 15. Minus 5 times 3 is minus 15. Bingo, it checks. Fair enough? Okay. So my song and dance is simple. If you can factor, that is your fastest way to solve a quadratic equation. Now, unfortunately, they won't all factor. All right? Now, the next thing we're going to do is look at something called the square root method. Okay. Look at the original problem. X squared plus x squared is equal to 9. The square root method in all of its glory is very, very easy, but you have to have it in the right order, Daniel, for it to make sense. So I'm going to take the square root of both sides. Square root of x squared is what? Kevin, what's the square root of x squared?
3.
3. What's the square root of 9?
3.
3. I got x is 3, but I got a little problem here, Trinity, because this is a second degree equation. I'm supposed to get 2 answers. I wonder what happened to the other one. Any takers?
It's the, is it because it's the absolute value?
That's a big deal, and we're going to talk about that absolute value bit, because how much is minus 3 times minus 3?
It's also 9.
Positive 9. So 9 has 2 square roots, a plus 3 and a minus 3. Do y'all buy that?
Yes.
Yeah, that's crucial that you buy that. Fair enough. Now, you're right, Daniel. I want to talk about this thing right here. The square root of x squared is the absolute value of x. This is one of your homework problem, by the way. True, false thing. If he just says the square root of x squared is x, that's wrong. It has to be the absolute value of x, and the reason is very simple. If I put in a 3 there, how much is the absolute value of 3? It's 3. But how much is the absolute value of minus 3?
Still 3?
It's still 3, and that's the reason that this is a true statement that we have right here. Agree? Okay, so watch this mess. If you got a problem in this form right here, the left-hand side, the whole mess is squared, and then I got me a number over here. Well, I take the square root of both sides, but the square root of x plus 2 squared is just x plus 2. That makes sense? Now, on the right-hand side, we've just got through doing that. The square root of 9, I'm not going to write down just 3. I'm going to write plus or minus 3, right? So what that says then is that my answer, bring this 2 over, so I got minus 2 plus 3, and I got minus 2 minus 3. Minus 2 plus 3 gives me 1. Minus 2 minus 3 gives me minus 5. Agree? Now, one more time, Kevin, you told me a while ago to check a problem, all I do is plug it in. So let's try the minus 5. Minus 5 plus 2 is minus 3, is that right?
Yes.
But Daniel just told us minus 3 squared is still 9, agree?
Yes.
Now, certainly if I plug in the 1, it's going to work because 1 plus 2 is positive 3, and 3 squared is still 9. So I'm telling y'all, if you have the square, if you have it set up like this, the square root method is a real fast method to work these problems. Fair enough?
Yes.
Okay. Now that brings on the next biggie. But before I get to it, let's go through a couple more things. Let's let this be the original problem. X squared plus 6x plus 9 is 25. Now let's do this factoring bit. On this thing, don't you agree that 3 and 3 would work? Because if I added them together, it would give me that 6, right? Now, why do we say that 36 is a perfect square?
Because it can square root into a number without a decimal.
That's right. In other words, it's 6 times 6. Is that right? And we say that 25 is a perfect square because it's 5 times 5 and so forth, right? Now, so if I got x plus 3 times x plus 3, can I write it again as x plus 3, the whole thing squared? Now, look at it. This is the right same type problem that we just got through doing. I'm going to take the square root of both sides and I get x plus 3. On the right side, the square root of 25 is 5 and minus 5. So I get two answers. Minus 3 plus 5 is 2, and minus 3 minus 5 is minus 8. Well, let's check the easy one. Let's put the 2 in. 2 squared is 4. 2 times 6 is 12, right? 12 and 9 is 21, plus 4 gives me that 25. Fair enough? So if I can make it look like this, Daniel, I can take the square root of both sides, and that's a pretty fast way of doing it, correct? Okay, so that brings on the next topic then. And the next topic is what we call a perfect square trinomial. Now, you just got through telling me 36 was a perfect square because it's 6 times 6. 49 is a perfect square because it's 7 times 7, and so forth. So if I just give you x squared plus 10x, and I say, what number you're going to have to add out there to make it a perfect square trinomial? It's going to be 25. Do you see the easy way to get that 25? There's a surefire method, folks. That surefire method is simple. You look at your middle term and you take half of it. What's half of 10?
5.
5, and 5 squared is what? 25.
25.
And it works, Daniel, every time. Every time, okay? Now look at the separate example I give you right here. It was x squared minus 8x. What's half of 8?
4.
And 4 squared is what?
16.
16. So it's going to be x minus 4 and x minus 4. Now, in the top one up here, everything is positive, so it stays positive. Why did I have to use minus 4 in both of these down here?
To create the -8, but multiply to 16.
That's right. The -8 in the middle dictates that one of those signs has to be negative, right? And you told me a while ago that every time the back end number is positive, it got to be the same sign, right? So it has to be a negative and a negative, agree? So what it says then is that thing going to factor into x minus 4. That make a little bit of sense? Okay, I hope it does, because the next page is where we're going to start trying to use this method. Okay, and this is one of your homework problems. Your homework problem is x squared minus 5x. And then he says complete the square. Don't back off of it. You take half of 5. Well, let's go back to the 4th grade. Half of 5 is 5 over 2. Is that right? You didn't know about decimals in the 4th grade. That didn't come along until later. Okay, Daniel? So, and that's what I'm preaching. You write 5 halves. But also in the 4th grade, you learn how to multiply 5 halves times 5 halves. Doesn't it give me 25 fourths? Multiply the numerators, multiply the denominators, right? So this thing right here is going to be my perfect square trinomial. And its factors are going to be x plus 5 halves squared. Don't worry about the fraction. In fact, don't put the decimal in it. He don't want the decimal in it, right? Okay, now for the biggie. And I want you to put this in your notes. Title this for me. Solve by completing the square. Solve by completing the square. You got one like it on the test, and they're going to ask you to do that. Trinity, are you still with us?
Yes.
Thank you. Okay, here's the problem. X squared plus 10x plus 2. And I'm telling you ahead of time, Kevin, people don't like this procedure because it's got steps, and you have to follow the steps in the correct order. The first thing you're going to do when you solve by completing the square is you're going to get nothing but the x's on the left side. So that's x squared plus 10x. So that means that I had to move this 2 to the other side, and I got minus 2. Well, I'm being kind to us, Daniel. I'm using numbers that we already know. To make it a perfect square trinomial, half of 10 is 5, and 5 squared is 25, right? Now, this is an equation. So I got to balance it. If I add 25 to the left side, I got to add 25 to the right side. Now, on the left side, it's going to factor in x plus 5 squared because we made it a perfect square trinomial. On the right side, I get minus 2 plus 25 is 23. And now I'm off and running. I can do what we've done the last 3 problems. Take the square root of both sides. Square root of this is x plus 5, the square root of 23. Now get used to this, Daniel. When you take the square root of both sides, we have to put the plus and the minus down, right?
Yes.
Okay, all of us remember that. When you take the square root of both sides, you got to use the plus and the minus. Now, so I get 2 answers. Minus 5 plus the square root of 23, minus 5 minus the square root of 23. And this is certainly one that I want you to look at and make sure that you write the answer the way Course Compass does it. I think this is the way he writes it. Minus 5 plus the square root of 23, comma, minus 5 minus the square root of 23. I don't think he leaves the x's in it. Please look at his example to see. So we have solved this problem by completing the square. Let me go through the steps one more time. You get nothing but the x's on the left side. You look at the middle term, you take half of it, and you square it, and that's what you add to both sides. And then you can take the square root of both sides. Okay, so we got 3 methods so far. I can factor, I can take the square root of both sides, or I can complete the square. The last method to solving quadratic equations is to use the quadratic formula. And we said when we started this mess, ax squared plus bx plus c represents every quadratic equation. It has an a and a b and a c. Now I'm going to tell you this, and maybe you want to go ahead and put this in your notes right now. If b or c is 0, never use the quadratic formula. Because if b or c is 0, either you can take out a common factor or you can use the square root method every time. Okay, let's take the same problem that we just had. The problem that we just had was x squared plus 10x plus 2 is 0. So, Kevin, do you see in this problem that the a value has to be 1? A is a number in front of x squared. So in this problem, it is
Yes,
1.
I see it.
Okay, and B is 10 and C is 2. Is that right?
Yes.
Now, Daniel, in your physics and in your chemistry, how did you use formulas? What did you do with them?
You plug them in.
You just plug in, and that's the big deal. Just plug it in, plug it in, plug it in. And that's the reason that many people just say, hey, I'm not going to worry about them other 3 methods. Quadratic formula, you just plug in, you worked every time. And I'll agree with that. But I'll agree that it's a whole lot more time consuming. Watch it. So we're going to plug it in. This is my formula up here. B is 10. So I got minus 10 plus or minus the square root of 10 squared minus 4 times 1 times 2 divided by 2 times 1. Now, so this is 100 minus 8 gives me minus 92. And now we're hung up with a little problem because we're all reliant on the calculator nowadays, Daniel. Not many people do things in our head anymore. And that's an unfortunate thing because your brain is a lot better than that calculator. I want you to look at this 92 right here. I'm going to give you a little hint. When you have a big number like that, you need to see if you can bust it up. Well, Trinity, I'll back off a little bit and I'll let you say, okay, let's let the calculator do some of the work for us. So in your calculator, you start dividing this thing by perfect squares. Well, the first perfect square is 1, the next perfect square is 4. And it so happens that when you divide 4 into 92, you get 23. Now, you got lucky, Kevin. 4 into 24 give me 93, but the square root of 4 is how much?
2.
2. So I can bring that 2 out front right here. And then I got a square root of 23 left in there. Now look at it. I got minus 10 plus or minus 2 square root of 23 divided by 2. Well, 2 cancels into 10 5 times, and 2 cancels into 2 1 time. So I get minus 5 plus the square root of 23 and minus 5 minus the square root of 23. Look at it. That's the same 2 answers we got a while ago by completing the square, right?
Yes.
Now, I'm going to say it again. If you want to just stick with the quadratic formula and say that's the way I'm going to do it, then power to you, you can do it that way. Fair enough? But
Yeah.
the other method, if you give me a problem, Daniel, where the middle number is even, I'll complete the square and beat you every time. It's that much more simple. If the middle term is even, you can make it a perfect square trinomial. Very, very simple. Okay. That was section 1.2. And there's one thing I left off of that. Let's go ahead and add that to it. B squared minus 4AC. B squared minus 4AC, that's the part that's underneath the radical in the quadratic formula. Is that right? B squared minus 4AC has a name. It's called the discriminant. Well, but it does exactly what it says. It discriminates as to which type answers you're going to have. And here's what it boils down to. If B squared minus 4AC is equal to 0, then you get 2 equal answers. And you say, well, why is that true? Well, let me give you an example. If we end up with this, 3 plus or minus the square root of 0 divided by 3. Well, how much is the square root of 0? It's 0. How much is 3 divided by 3?
0.
No, 3 divided by 3. 1.
1. Sorry.
Yeah. So I get 1 plus 0 and 1 minus 0. But how much is 1 plus 0?
0.
Oh, how much is 1 plus 0? I'm adding them, not multiplying.
1.
1. How much is 1 minus 0?
1.
Still 1. So every time the discriminant comes out to be 0, you get the same answer. You get the same answer twice. In this case, we got 1 plus 0 is 1, 1 minus 0. Okay. Now, and this is a big deal. B squared minus 4AC is greater than 0. You're going to get 2 unequal answers. Let me go get another sharpening pencil. All right, let's give it a try. Let's suppose that this is my problem.
Can you push the notebook up so I can see the, yeah, thank you.
That better?
Yes.
Okay, so let's say I got 5 plus or minus the square root of 16 divided by 2. Okay, so in this particular case, how much is the square root of 16? It's 4. Agree? So I get 5 plus 4 divided by 2 and 5 minus 4 divided by 2. That makes sense? So let's try it one more time. If the discriminant is 0, you're always going to get the same answer twice. If the discriminant is positive, such as this 16 right here, you're going to get 2 unequal answers every time, right? Now, I want y'all to put this in your note because this is a big help, Trinity. If the discriminant comes out to be a perfect square, then your answers are going to be rational numbers. Daniel, does that make any sense? Every time underneath the square root comes out to be a perfect square, then you got rational numbers. Agree? Because the square root of 16 is 4, square root of 100 is 10, and so forth. Now, if it comes out to be square root of 5, that's a different ballgame, and that's what we're fixing to talk about here. So the discriminant can save you a little trouble. In fact, the reason I really brought that up, Daniel, is this. If the discriminant is a perfect square, you could have factored the problem to start with. Yeah, put that in your notes, please. If the discriminant is a perfect square, the original problem will factor every time, because that means that you got whole numbers to deal with. If it's a perfect square, factor to start with. Okay, now the biggie. We've just finished section 1.2. This is section 1.3 that we're in now. Complex numbers. Complex numbers, we have to deal with the I. Now, way back there, in fact, I don't know how they actually thought of something like this, but they did, okay? The square root of minus 1, there's no such thing. So they called it I. They could have called it A, B, C, D, E, F, G. It doesn't make any difference. But they called it I. And universal, in every language, they call it I. Fair enough? Now, so by definition, the square root of minus 1 is I. Well, watch what that does. How much would the square root of minus 9 be then? How much would the square root of minus 9 be?
3i.
It'd be 3i because the square root of 9, y'all have already told me, is what? 3. But the square root of this negative is always going to be what? I. Kevin, that makes sense? Okay. But I want you to watch this mess. If the square root of minus 1 is I can raise an equation to the same power on both sides. The square root of anything squared just removes the radical. And then over here, I got I squared. Now, this is a kicker, Daniel, and that is a big kicker. I squared is minus 1. So as crazy as it seems, folks, when you square the I, you end up with a real number and not an imaginary number. That's a little quirk that you can worry about way on down the line somewhere or another, okay? Now, but I want you to keep in mind though, every time you see I squared, you can use minus 1. Fair enough? Okay. Now, so let's make us a problem. Let's take 3 plus I and multiply it by 3 plus 4i. So we're going to follow it. 3 times 3 is 9. Outside is 12i. Inside is 3i. Last terms is 4i squared. Well, 12i and 3i is 15i. Where do you think I got this minus 4 from?
I squared equals negative 1.
Right. The I squared here is negative 1, right? Now, so I got 9 minus 4 is going to be 5. So it's 5 plus 15i. Now, I want you to notice what we don't do, Trinity. We don't add this 5 and 15 and get 20. In fact, you can't add them. They're not like terms. One of them is a pure whole number and the other one is an imaginary number, right? I don't fall for the trap. You got some homework problems that says this, 3 plus 2i plus 6 plus 5i. This says you're going to add them. You're not multiplying them together. How much is 3 plus 3? I mean 3 plus 6. Going to give me 9. How much is 2i plus 5i? Going to give me 7i. Agree?
Yeah.
Okay. You got a couple of definitions in this section, and I want us to pay pretty close attention to them. Now, you got rational numbers and you got irrational numbers. Our rational numbers are the ones that we deal with nearly all the time. A rational number is any number that can be expressed as a fraction of two whole numbers. And that covers all of them. The square root of 9 is rational because isn't that the same as 3 over 1? Right. Now, but the square root of 5 is not rational. If you got a calculator, you hit the square root of 5 and it's going to give you 2.236. That's after 3 or 4 decimal places. When you get right down to it, Daniel, there's no such thing as square root of 5. The square root of 5, you can carry it out as far as you want on a computer. It will never repeat. It will never terminate. That's the reason that it's called irrational. Now, there's another irrational that y'all are all familiar with, and they've written books about it. I don't think they've ever made a movie about it, but pi. You know, pi is 3.14159, but it just keeps going on and on and on. And it's crazy where pi comes from. It's the rate. It's the circumference of a circle divided by, and that gives you pi divided by the diameter. And it's always going to be 3.14, whatever that number is. But it is irrational. Okay, but let's get to some problems. First of all, back from the 4th grade, how much is 4 times 1? I'm not being funny. How much is 4? How much is any number times 1?
Itself.
Itself. How much is any number divided by itself?
1.
1. The only exception to that, and Kevin, this is a big exception, and we have to all buy that. How much is 0 divided by 0?
0 divided by 0?
Uh-huh. That's a biggie. Don't put your foot in your mouth.
1.
That's what most people say.
And I'm wrong.
It's nothing. You can't do it. You can never divide by 0. Never divide by 0. And that's in a different ball game. But we can divide by a number by itself, like 3 over 3 or 5 over 5, right?
Yeah.
Okay. Now, I'm going to cover this up, and I hope you can see the other pieces of problem. The problem is 2 divided by 3 plus the square root of 5. Write that down. 2 divided by 3 plus the square root of 5. Now, Daniel, for some crazy reason, I'm going to multiply the top and the bottom by 3 minus the square root of 5. Do y'all agree with me that 3 minus the square root of 5 divided by 3 minus the square root of 5 is 1? We just got through preaching. A number divided by itself is what?
1.
1. Okay, as long as it's not 0, right, Kevin?
Correct.
Okay.
Correct.
So we're in good shape then. So I took this original problem, whatever it was, and I multiplied it times 1. And y'all told me a while ago, 1 times anything, don't change it. Okay, so on the top, I'm going to fold. 3 times 2 is 6, and I got 2 times the square root of 5. Now on the bottom, and I want you to watch this mess. We're going to fold the bottom. First is 3 times 3, outside minus 3 square root of 5. Inside plus 3 square root of 5. Last term, plus times minus is minus the square root of 25. But watch what happens. What happens with minus 3 square root of 5 plus 3 square root of 5? They add out, agreed? Because a number minus itself always gives me 0, correct?
Correct.
Now, So all I got left then is 9 minus the square root of 25, which is 5. So that gives me 6 minus 2 square root of 5 divided by 4. Now, if you wanted to get fancy, you could divide everything here by 2 and get 3 minus the square root of 5 divided by 2. I want you to put it in your notes. What we just did, folks, was rationalize the denominator. Rationalize the denominator. In other words, we made the denominator a rational number. When I got through with that denominator, it ended up being nothing but 4. It was irrational to start with because it had the square root of 5 in it. Now you got a homework problem just like that. In fact, I think you got one on the first test just like that. So the big deal is this. How, Daniel, did I pick 3 minus the square root of 5? Well, there's a fancy word for it. And it's called the conjugate. The conjugate of any number, you simply change the middle sign. 3 plus the square root of 5, its conjugate is going to be 3 minus the square root of 5. It's that simple, folks. Don't make it complicated. But listen carefully to what I said. You only change this sign. You don't change the sign in front of the 3. You change this sign.
Sorry, Professor, I have to go to work. I'll tune in next time.
That's great, and I'm glad you hang around with me because it makes it a whole lot better for me to teach when I got people interacting with me. Have a good day. Fair enough? Watch the video. I'm going to post it, okay? All right. Kevin, you still with me?
Yes, sir.
All right, we got about 3 more minutes, maybe less than that. Okay, the original problem this time, Kevin, is 2 plus I divided by 5 minus I. Well, believe it or not, Trinity, I is not a rational number. Therefore, I can't leave I in the bottom. So we're going to do the same thinking, exactly the same thinking. I need to get the conjugate of 5 minus I. And the conjugate of 5 minus I is 5 plus I. Kevin, that make a little bit of sense?
Yes, it does.
All you do is change this sign, right? Now, I want you to watch what happens, Kevin. We follow the top. First is 10, outer 2I, inner 5I, the last is I squared. And on the bottom, I left off the step. The bottom is going to give me 5 times 5 is 25 minus I squared, because we know the middle terms are going to cancel out because they're going to be plus 5I and now, so on the top, I've got 10 minus 1, and that gives me 9, 7. And on the bottom, 25 plus 1. Now, how did I go from minus I squared to a plus 1? How much is I squared?
I'm
Negative.
sorry, what was that?
I squared is -1, right?
Correct.
Now, negative times a negative is positive. So that's
Right.
where this plus 1 comes from. Now, get this and make note of it. Course Compass is always going to write the complex numbers in the form of A plus BI. So in this case right here, it's 9 over 26, that's your A term, 7 over 26, that's your B term. And if you don't write it like that, he's going to mark it wrong. If you write it like this, he won't give you credit for it because it's not written in that form. Okay. I picked one here just to emphasize the fact that these quadratic equations that you're going to solve, in this case, I'm going to use the formula because I want to talk about the discriminant. In this problem, the A is 1, the B is 2, and the C is 8. So we plug in, and we end up with -2 square root of 4 minus 32. And 4 minus 32 is -28. And we got that same song and dance. 28 will break up into 7 times 4. The square root of 4 is 2, and the I comes out front. So I get 2 answers. I get -1 plus the square root of 7 and -1 minus the square root of 7. and then I get the I. The I was the fact that the 28 up here was negative, and the square root of a negative number, you always have to put the I down. Okay, last one. Kevin, look at the degree of this thing. It's 4th degree, is that right?
Yes, sir.
So how many answers am I supposed to end up with?
4.
4. I want you to watch this mess. Believe it or not, folks, this thing factors. X to the 4th is x squared times x squared. The factors of 16 are 16 and 1. Outside would be 1x squared, inside 16x squared, 1x squared, and 16x squared gives me that 17. So I picked you one that's easy to factor. Now, we make two little problems out of it. X squared plus 16 is 0. Bring the 16 over. You take the square root of both sides. The square root of minus 16 is 4i. Don't forget, when you take the square root of both sides, you have to use the plus and the minus. On the other one, you bring the 1 over. Square root of minus 1 is plus or minus I. Fair enough?
Yes, sir.
I think we've done it all. We are in good shape. Good luck with section 1.2 and 1.3, and I appreciate you staying and making the full class with me. Did you get the note that we're going to start?
Yes, keeping up is not a problem.
My problem with the other time, I was running the classes back to back, and I didn't realize that it was taking too much time for my computer to save that last session, and it was running over into the next one. But I think we got it solved, and we'll see you Thursday then, okay?
Yes, sir. Thank you. I appreciate it.
Have a good day. Bye, Trinity.